Hello everyone, this is from the TA for ELEN6320 millimeter wave IC design. In this video, I will show you how to start with Cadence IC design tool, as well as some basic commands in Cadence that allows you to do question 3A from book 1. So after you log into the server, this command console gonna show up, and the first thing you want to do is to go to the directory that Cadence store all the library you're gonna use. So you can type ls. So in here show a lot of like different directories in sort of like in blue line, blue color. So the directory I need to go to is called Cadence, and so I type cd cadence, and from here type virtuoso to start the Cadence GUI. So this one is a Cadence GUI, and from here you go to Tools, Library Manager. So another window gonna show up, and in here you're gonna see like three other sub windows. The first sub window show all the libraries contained in this directory. Let's select like let's say anaglyph, and if you select one library, um, the second sub window show you all of the cells or schematic defined in this library. And let's say I want to start up a new project for this class. So you can go to, you're gonna need to create a new library basically. So from here you go to File, New, and Library. Just type ELEN6320 underscore lib and hit OK. In here, you select attach to existing technology library, and select analog glyph. Okay. Yeah. So this is a library I just created. So I'm gonna create a transistor model in this library. So in here, you go to File, New, Cell View, and so you name your schematic. In here, I name it just mouse symbol. Make sure the view is schematic and type is schematic as well. Hit OK. Another sub window gonna show up like this, and in here you can draw your schematic. I will draw the small signal model of the transistor in here. So in order to let's say we want to create like a gate resistance. So in order to create a resistor, you hit I, and in the library select analog glyph, self it resistor res, and let's just not worry about the resistance value in here, just place it here. And do the same thing. You can create capacitor. And another resistor, for output resistance. For the chance conductance, you can go to the uplift and select VCCS for voltage control current source. And then make all the connections. Okay, so I should mention that in here I'm trying to create a symbol, a parameterized symbol. So basically with the symbol you can represent your circuit into like just a one block of schematic, and this is a very useful way in case you need to duplicate your schematic or you need to build a very complicated system. So in order to create a symbol, you have to first of all you need to create a schematic like this, and you have to create a terminal. For my transistor model, I need to create 3 terminals: the gate, the drain, and the source. So if you hit P, like one window want to show up is called create pin, and you type gate, and direction is just say that's input output right here. Another one called drain, put it here, and another one called source, put here, and then you make the connections. Now I want to well, make sure this one is like some voltage going to apply to the voltage control current source. Let's call this one. So in order to label a wire name, so now hit L and type the wire name. Let's say VGS here. Click here and VGS and click here. Basically, what I just did is I just assign the voltage at this node equal to this node right now. So in order to create a parameterized model, you need to go to the resistance value and select, just say P par. In the resistance field, type in P par and RG. Do the same thing for other capacitor and chance conductance. CGS. CGD. GM. Okay, so that is this for like the schematic model. Now you would need to create a symbol for this schematic. So from here you can go to create cell view, and from cell view just select OK, and so you want the left pin going to be gate, the right pin is drain, and the bottom pin is the source. Click OK. So now in here you sort of have like a very basic rectangle that represents the transistor. You can use the tools in here to draw, like to make the symbol more like meaningful, but in here I just keep it at a simple rectangle. And then after that you just close it. Yeah, so this one is your symbol. You can see in the third in the view sub window, there's a schematic that show you like the schematic of the symbol, and the symbol that show you like the symbolic image of the symbol. And now you want to create a test bench to test this symbol. So in here you go to, in the library manager, go to File, New, Cell View. So we're gonna create a new cell view to create a test bench for the symbol. So in here you just say you're gonna name the new cell gonna be mouse symbol and underscore TB for test bench. Yeah. So so you need to instantiate a symbol again. So again, press I, and in the library, select the ELEN6320 lib underscore lib, and select mouse symbol. So in here now you're gonna see like all the parameters you can set for this transistor symbol. So you have like CDB, CGD, CGS, RG, GM, and R0. So in the I just follow the homework. So basically you need to set CGS to 95 femto, CGD to 21 femto, CDB to 47, RG is 5100, GM is 116 millisiemens, and so R0 is not specified in the homework, so I just I just leave it to very high number, so just say 1 mega, and you can select here. Yeah, so first of all, we want to measure the Fmax of this transistor. So you go to again, you create the instantiate like the port. So in the library, select analog clip. Cell is use port. Make all the connections and make sure like all symbols are grounded. Okay. Now you finish the schematic of the test bench that has the transistor and 2 ports to measure Fmax. Now you want to create the simulation. So in the schematic editor, go to Launch ADEL. So in the analysis, you just right click on the empty space and select edit. And we want to do like SP simulations, and select the 2 ports, port 0 and port 1, frequencies. And so in here we want to sweep the frequencies, and we want to detect at which frequency the um, Gmax, or the gain of the transistor, is 1. And frequency and sweep range, you define the start frequency and the stop frequencies. So the start is let's say 1 gigahertz, or let's start with like 100 megahertz, and stop at let's say 500 gigahertz. And just leave the sweep type to automatic. Yeah, and select OK. So now we have specified the simulations, and we can start the simulation. So click or left click this green button, this play button. So when the simulation is completed, you go to the ADE sub-window and select Results, Direct Plot, and Main Form. So in here, pretty much you can plot any measurements you want to plot. So in here, I just want to plot the Gmax, that indicating the gain, the maximum gain of the transistor. So select Gmax in the functions, and in the modifier, select dB10, and select Add to Output, and click Plot. Yeah. So in here we can see the plot that represent the Gmax across frequencies. To make the trace like easier to see, you can select the trace and hit Q to show the properties. And in the type style of the line, select instep dot, select solid. Click OK. Yeah. So you're gonna see like at which frequencies the Gmax is like 0 dB, that indicating the fmax. So if you like zoom in, you can zoom in by keep shift and scroll the mouse up. Yeah. So in here you can sort of see like at let's see, at sort of like 7.8 gigahertz, Gmax is 0 dB, and so that indicating the fmax of this transistor model is 7.8 gigahertz. You can also create like a vertical line to see the trace to see the trace earlier by select V. So this one you can also sweep the line to see at which frequencies the what is corresponding Gmax is. Yeah. That is this for this test bench. For the homework, you need to create a distribution like a distributed model. Basically, you need to create like a multiple transistor like this, and you also need to modify the symbol so that you can create like a cascading. You can cascading the transistor. One more thing, if you want to modify the symbol, you can select the symbol and hit E. So in here you can select open for edit or for read. So in here I just select edit and open in current tab, hit OK. So this one show like another like schematic definition of the symbol. If you want to make any change to the symbol, you can make it from here. If you're done with editing, you can go back to your like upper level schematic by hitting this up button. So that is it for the tutorial for today. I hope you can follow the tutorial thoroughly, and good luck with the homework.